Hey, what's up, guys? My name is Ogechi Igboanugo. I'm a Cisco CCIE, Cisco Certified Internet Network Expert for routing and switching in enterprise networks. I'm also a JNCIE, Juniper Network Certified Internet Expert for routing and switching enterprise networks and service provider environments. Okay, cool. Today I want to talk about routing, and let's get started. So what is routing? Routing is a process of enabling reachability between networks. Routing is usually performed by devices that can perform routing capabilities, such as routers, and there's some layer 3 switches that have that capability too. Well, basically, it's all about enabling reachability between networks. So let me give you an example. Say you're in Miami, Florida right now, and you're trying to take on a road trip, right? A road trip to another city in Florida as well. And you bring up your phone, as you can see on the screen, you bring up your phone and you look up your GPS, right? And the GPS usually has a map of reachability, how to get to destinations, basically, right? So you're in your house right now, and that's your home network, right? So this user on the screen is in his home network, and he's trying to get to another destination, right? But he doesn't know how to, right? So he has to consult the help of a router, right? So your Google Map is just like this is an analogy, but the Google Map is just like, say, a router, and the Google Map has the knowledge of destinations. It knows how to get to here and there. So you bring up your Google Map and you search and you say, hey, I want to go to this city, right? And the map pops up and tells you how to get to that city, different destinations, right? That is just like routing. It's enabling reachability from one network to another network. And routers have that map, that total topology, that map of how to get you from point A to point B. So just like on the screen right now, you can see the different cars on the screen, right? So basically, you could be this car right now, right? And now you got in your car, and you have your Google Maps open, right? And you're trying to get to another destination. This is how routers think, right? So they enable this guy in this car right now to be able to get to his destination, right? So now there are multiple destinations that he can see, right? He's probably on the highway right now, on the expressway or highway, and he's trying to figure out how to get to a destination. So the GPS could tell him, oh, take this path, right? Or he could take another path, right? But at the end of the day, you're trying to find the shortest path or the best path, across the entire map. Just like how GPSs do, they will tell you the shortest path to get to a destination or the best path to get to a destination. And that's similar to what routers think. So basically, routing is enabling reachability between destinations from point A to point B, right? Or between multiple destinations. It allows reachability between networks. So there's a concept of local area network where you're just talking in that local area network, right? So anything in a local area network can talk to each other. But when you're about to leave your local area network and you're about to talk to another network, then you need routing. So routing enables that reachability between two or more networks. The concept of routing is all about communication. It's all about telling the other router, hey, I know about these routes. I want to share them with you. Tell me what you know about. Now, looking at my screen, you can see a bunch of guys all talking to each other, right? So this guy here, his name is Gary, and the other guy is Peter, right? And they're both sharing information across to each other. Now, each of them, after discussing, they're now aware of certain information, right? And they're communicating basically, right? Now, Gary now knows of whatever information that Peter has told him about. That is what routing does. So in order for routing to happen, to occur, right? Routing can be done statically, or it can be done with a routing protocol. What is a routing protocol? A routing protocol is a protocol that determines the ways routes are handled, allowing for reachability between networks. It's the language of routers on how they discuss knowledge about routes. So routing protocol is a language of routers that enables them to communicate, to share routes between each other. For example, if this guy was speaking a routing protocol in English, and he tells Peter, hey, I know about this route 10.1.1.0/24. And I know about 172.16.1.0/24. But he's saying it in English, right? And if Peter is a French guy, and he doesn't understand English, he's not going to understand what Gary's talking about. But if Peter is speaking the same language as Gary, right, then they would understand, and he can understand that Gary is trying to share these networks to him. That is what routing protocols do. It's a language. They both understand. They have to both understand the language, right? And that way they can communicate and share routes between each other. They can have a good conversation. That's what routing protocol is. You know, both routers have to acknowledge and understand that protocol, and they both accept it and they share information. Going to the next screen. So today we'll be talking about, we talked about routing already, right? We talked about routing protocols. What is a routed protocol? A routed protocol is a term that usually gets confused with routing protocol. So a routed protocol is that information that is being routed by a routing protocol. Are protocols that are carried by a routing protocol, basically like IPv4. IPv4 information can be shared by a routing protocol, and it is a routed protocol. IPv6 information also. AppleTalk, back in the day, AppleTalk also was a form of communication, right? All those protocols are also protocols that are also shared by routing information, by routing knowledge. So that's what a routed protocol is. Routed, as the name implies, is something that has been routed by a routing protocol. So let me explain this concept of routing protocols and routed protocols with a simple analogy. Now, looking at my screen, you can see there's a family driving, right, on a road trip going to some destination. Now, a routing protocol could be likened to the driver. Let me get my pen. Routing protocol could be likened to this driver right here. He's driving this car and is the one that's controlling the movement, right? The manipulation, the ability for that car to move from point A to point B. So he's driving the car, right, from one point to the other. So he's driving that traffic, right, towards a destination. The driver would be the routing protocol. Now, because this could be the different types of drivers, right? They're fast drivers, they're slow drivers, right? So people are different with different skills of driving. So this guy is driving the traffic and is driving the car from one destination to the other. And now the routed protocol could be everything that is being conveyed from point A to point B. So it could be this luggage. This luggage here could be an item that is being transported from point A to point B. This could be a routed protocol. For example, like AppleTalk, right? Like IPv6, that's a routed protocol. Also, the passenger in the car, this girl, his girlfriend, she's also a passenger, and she's also a routed protocol as well. So she could be IPv4, while the baggages could be AppleTalk, and the other baggage could be IPv6. And basically, the car, the vehicle, the medium of transportation could be the router, right? Or the layer 3 switch that has the routing capabilities. So now the routing protocol with the driver driving the traffic, a functionality in the car driving the traffic from point A to point B. The routed protocol are the baggages, the luggage, the anything that is being conveyed from point A to point B, anything that is transported, and that would be the passenger and the luggage. So in the eyes of these guys, right, if you can see my screen right now, you can see a bunch of workers on your computer and they are just working, right? They're basically just working. They have what they see is that what they care about is that their computer is online and they can reach the internet, right? So you can see this dude right here, his name, let's say his name is Jide, right? He's Nigerian, and his colleague here, her name is Sarah, right? And the next guy is Peter, right? Basically. So all these guys, all they care about is that they're on their computer and it's working. They can surf the internet, they can browse, but they don't care about what's happening in the background. They don't know that their computer is probably plugged into some wall jack, right? They don't know how wiring is done in the building, right? And if there's an IDF room that has all the network gear, or an MDF room that has all the network gear, right? They don't care if there's a router somewhere in the building that connects them to the internet. They don't know about all these things. All they care about is that it's working. And if it doesn't work, They just call the IT guy, right? And you can see Sarah here, she's on her laptop, and Peter's on his laptop also, and they're both surfing the web, right? They're probably getting some Wi-Fi connection, right? Basically, right? So that's all they care about. But now there are different ways of sharing routes from one router to the other. There's a static way called static routing, and as the name implies, it is static in nature, basically. So you manually tell the router, hey, I know about this route, and to get to me, take this path. But it has a very large administrative overhead because you have to manually configure every path in the network. And the other alternative is called dynamic routing protocol. Now, these protocols, as the name implies, is dynamic. So basically, it requires is a protocol that is dynamically learning about routes, dynamically speaking the language of routes, right, and sharing that information to other routers that understand that same language. So dynamic is more of an automatic way of ingesting, and telling routes, basically, while static is a manual method. And there's also another umbrella called default routing. So for default routing, it's somewhat like static routing in some way, but it really isn't. So for example, if you have this topology and you have router here, this is router 2, this is router 3, and you have another router 1 here connected to router 2, connected to router 3, and there's a destination here 3.3.3.3.3. Router 1 is trying to reach that destination, right? So what could happen is maybe let's say router 1 was a Cisco device, right? You can go into this Cisco device and say no IP routing. That's a command you can put in the command line, and that will disable IP routing on this device and make it look like an end host. And you can go in and say IP default gateway, and you point the IP address of router 2 as its gateway. So maybe router 2's IP address here might be 10.1.1.2. You will say IP default gateway 10.1.1.2. You put that configuration on router 1. So basically router 1 is acting like a end host, and it knows to point to router 2 if it's trying to reach networks that are outside of its reach. And that's it. And basically from router 3, maybe router 3, you could inject a default route so that router 2 could learn that default route, maybe through a routing protocol between router 2 and router 3. So the default route is learned on router 2. So basically router 1 just points the default gateway to its gateway of last resort, which is router 2, right? Just like a computer. Then router 2 has knowledge of a default route that it learned from a protocol. That's default routing. That's basically default routing simplified. Okay, cool. So now for static routing, if you have a network like this, let me get my notepad, 1 sec. Okay, if you have a static routing, if you have a network like this of 4 routers, router 1, router 2, router 3, and router 4, with static routing, you have to manually tell them, hey, if you want to get to this network 10.1.1.0/24 that this router 4 is advertising, we know that 10.1.1.0/24 resides on router 4. We have to manually go into the router and say, hey, to get to 10.1.1.0, go to this next hop. Then we go to the next router and say, hey, go to this next hop also. And we go to the third router and say, hey, to get to that network, go to this network also. And we also configure the return path, right? We have to also go to the destination router and tell it to manually go to this router to reach router 1. And we have to tell router 3 to go to this router to reach router 2. And we have to manually do the same thing from router 2 to 1. So you can see there's a lot of manual administrative overhead, right? You have to manually go to every router and tell it to reach that network, go that way or go this way. It doesn't really scale when you're dealing with a large network of multiple routers, like a large ISP, right? It's not gonna scale, right? So cool. There came routing protocols. Now routing protocols are dynamic, so they have knowledge of, they automatically share the routes when you tell them to share the routes. They can share a lot of routes at the same time, and they can learn multiple routes at the same time too. So it's more dynamic. There's an algorithm when it comes to routing, dynamic routing protocols. So that's the difference. Dynamic is more dynamic, and static is more manual. Now, there are a bunch of types of dynamic routing protocols. Basically, it's divided into two major categories. There is IGP and there is EGP. Now, IGP means Interior Gateway Protocol. Let me write that down. IGP means Interior Gateway Protocol, while EGP means Exterior Gateway Protocol. Now, what does this mean? So, IGP, meaning Interior Gateway Protocol, is a type of routing protocol that is really used within the confines of an autonomous system. So what is an autonomous system? An autonomous system, as the name implies, is an organization, an entity that is under one common administrative control. An autonomous system is spelled like this. Let me get a black pen. Autonomous system, right? For example, looking at the drawing, you can see a bunch of equipment, right? This could be one AS, and this could be likened to an office or a school, right? Or it could even be an ISP network, but one network that is under the administrative control of one entity, right? It's an autonomous system. Now, usually IGPs, like let me change the color. IGPs, like you could have an IGP like OSPF running in one AS, right? And in another autonomous system, this could be a different autonomous system, and it has its own number. And it could have another IGP like RIP running inside it, right? And this third one could be another autonomous system with a different number, right? And it could run maybe EIGRP as its IGP. But one thing that is common within all these ASs is that they would have their own IGP, right? Running within that AS. So the keyword is, the keyword really is IGP. The I is for interior, and interior means within the confines of the autonomous system or the AS. And now, when you want to route between autonomous systems, there you would find protocols like EGPs. So for example, when this AS10, you're trying to route between AS10, this could be a Verizon network, and AS20 could be, for example, maybe it's a AT&T network, right? So routing between two ASs publicly on the internet, right, you will need an EGP, and the E stands for exterior gateway protocol, right? And it's exterior in nature because exterior in that context means it's exterior to an AS, while IGPs are interior and they're built to be configured within an AS. And those are the two major demarcations between EGPs and IGP. Now, there are other factors like scaling, right? Now, EGPs are the routing protocols that are used on the internet, because the internet is a bunch of routers, right? All interconnected together, right? And different service providers have different ASs, right? That are publicly routable, right? So it's massive amount of routes and ASs on the internet, right? So you need a protocol that can handle that much capacity, and that protocol is EGP because it's exterior in nature. EGP, and a good example of an EGP is BGP, right? BGP is the EGP that is existing today. Now, IGPs, interior in nature, they cannot handle as much routes as the internet. They don't scale that much. So they're interior and they're built for small number of routes that are managing one entity's network. So that's the major difference between IGPs and EGPs. Now, organizations like internet service providers, schools, every organization that requires a public AS, they can get their ASs from an organization called IANA. And what does IANA mean? IANA means Internet Assigned Numbers Authority. So they go and they get an AS, a public routable AS, issued from this organization, because these ASs have to be unique on the internet, right? Because they identify an organization that has a common entity, that has a group of networks under one common administrative control. So types of IGPs we have, there are three major demarcations for IGPs, as you can see on my screen. There's what they call distance vector routing protocols, and there's link state routing protocols, and there's hybrid routing protocols. I'm going to explain what hybrid means in this scenario. So for distance vector routing protocols, we have a couple types. We have RIP version 1. RIP version 1 over here. Now, what does RIP mean? RIP means Routing Information Protocol, and there's been an evolution from version 1 to version 2. And they also had IGRP, Interior Gateway Routing Protocol, as well. Now, all these three are all distance vector routing protocols. And next we have link state routing protocols. There are two major types. Actually, they're just two major types, right? And they are ISIS, Intermediate to Intermediate System, and there's OSPF, Open Shortest Path First. Now, these two are link state routing protocols, and they're quite very popular in the routing domain of in routing, basically. And third but not the least is what they called hybrid routing protocol. So technically speaking, this was created by Cisco back in the day, and it was somewhat an enhancement of the old Interior Gateway Routing Protocol, IGRP. So this was an enhancement of IGRP back in the day, right? So it's kind of like an advanced IGRP, basically enhanced IGRP, that's the name, right? But basically it also borrowed some techniques from link state routing protocols, and definitely, so people just called it a hybrid because it has the best of both worlds. So we'll get into that, we'll talk about that later on. But these are the major types of IGP: distance vector, link state, and hybrid. Okay, cool. Now EGPs is the other umbrella, right? So when we talked about dynamic routing protocols, we mentioned IGP and we mentioned EGP. So for EGP, it's a lot more simpler, right? There's not a lot of divisions, right, in EGP line. So for EGPs, they are path vector routing protocols, and there are actually two types. One of them is, would I say, extinct or obsolete? But what the first one was, the old one was EGP, Exterior Gateway Protocol, right? It had one called EGP, but that one is obsolete right now, and nobody uses it really. Maybe in labs. But the routing protocol of the internet is the major EGP that exists today, and it's called BGP, Border Gateway Protocol. Now, this is the protocol of the internet, and there's a lot of extensible. It's very extensive, basically, right? And it's been enhanced over years, and now they have what is called multi-protocol BGP. You know, it's massive. You know, it can do a lot of things. It can do IPv4, IPv6. BGP is truly the protocol of the internet. So yeah, this is the picture, the big picture of routing protocols. Analogy, literally. So we talk about routing protocols and routed protocols. I also gave you an analogy, right, where I described the operation of routing protocols. I also talked about the big picture, the big umbrella of types of routing protocols. We mentioned static routing, we mentioned dynamic routing, and we mentioned default routing as well. Okay, cool. So now, just stay tuned to this channel. Remember to like my video and subscribe to my channel. I have a lot of videos for you guys. The next video, we're going to delve into the different types of routing protocols. I'm going to explain the differences between RIP version 1, RIP version 2. I'm going to explain the differences between the link state protocols, OSPF, ISIS. I'm also going to talk about BGP, the only EGP that is active and successful today. Okay, cool. Stay tuned to my channel. I remain your guy, your boy, Ogechi Igboanugo. I'm a Cisco Certified Internet Network Expert, CCIE, Routing and Switching and Enterprise Networks. And I'm also a Juniper Network Certified Internet Expert, JNCIA, for both enterprise and service provider environments. Stay tuned to this channel and peace. Thank you.